Okay, part C. One hint for the test. Just because there's a lot of words doesn't mean it's difficult, but it does take time to read all those words. So use your best judgment. I might skip it and go find other things that I can get done more quickly and then come back. At time equal 2, train A's position is 300 meters east. I'm going to stop right there. So I've got the train moving back and forth 300 meters east of the origin station. Aren't they clever? We call the dumb thing origin station because we call the center of this line the origin. Funny people. So I would write down the position of train A at time 2 is 300, like that. Write an expression involving an integral. Keyword write. That's good news. That means they're not going to ask us to solve it. At least we get some points for doing that. Involving an integral that gives the position of train A in meters from the origin at time 12. So that is absolutely the fundamental theorem, because, go to here, we're talking about an amount and a rate. The amount is the position. They want the position of train A at time 12. The rate is they've given us the velocity of train A. So, as it says in the golden notes right here, most important box on the entire page, if they give you a rate and they want an amount, that's fundamental theorem. So, I'm going to go back to here. That's why I have this written down right here. This is simply the fundamental theorem rearranged to find the position of the train at time 12. They said write an integral. I've done that. I wrote an integral, and right here I hit this period, I stop. Always stop at the periods. 1 point for doing that much. Keep reading. Use a trapezoidal sum. That's a Riemann sum. 3 subintervals indicated by the table to approximate this. Okay, be careful here. Sometimes people forget the 300. 300 is not a part of the Riemann sum. It is a part of finding the position of the train at time 12. The Riemann sum is going to approximate the integral. So I write down the position at time 12 is approximately, there's my 300. Now the Riemann sum. So I come up here. Oh, be careful as well. We're going from time 2 to time 12. Don't start at 0. So we need this time interval, this one, and this one. Trapezoidal says you take 1/2 of the 2 velocities on the left and right of the subinterval. So in this subinterval, I take the velocity most left and the velocity most right. I add them together, divide by 2 to find the average of the 2 velocities, and multiply by the width of the subinterval. The width here is 3. Then I do the same thing for each subinterval. The way they award points is the red box was 1 point. The green box, which is the trapezoidal portion, that's a point. If you remember to add 300, then you get the 3rd point. You actually do not have to do anything after the blue box. You do not have to go find this. You shouldn't go find this. You should stop at the blue box. And that would be a total of 3 points.